So, Unit 4, Day 7, identifying conics and solving systems of equations of conics. We're going to keep both of these kind of simple. Both of these can get kind of crazy, but we're going to keep them both fairly simple, and I'll show you why and how when we do each one. So first, identifying conics. Well, in general form, it might look like ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. I mean, you're looking at that, but you just did a quiz that had that kind of stuff on there. With one exception, there's one term in there that we have not seen yet. Yeah, the bxy. All the others you've seen before. What bxy does, if there's that term in there, is it rotates the conic. So you could have an ellipse that wasn't left, right, or up, down. You could have a hyperbola that was, off at some weird angle. Well, to allay your fears, we're not going to have any of those because those are really, really hard to graph. You can do them, but they're just really tricky. Like just thinking about the ellipse, like how do you know, A and B, if it's all crooked? Like we're not going to do those. So we're not going to have to worry about an XY term. We're not going to have any that have an XY term in them. So that's how we greatly simplify identifying conics. So we're going to identify by inspection. Now that's just a fancy way of saying just look at it and figure it out. That may seem to like oversimplify the issue. If there's no bxy term, but for us there will be no bxy term. So we'll be able to look at these and figure them out. And you may have gotten pretty good at doing this already. So let's say we got 2x squared plus 2y squared plus 8x plus 4y plus 6 equals 0. Now, we could do the whole solving thing, but I don't want to do that. I want to be able to look at that and figure out what it is. Well, it has two squared terms. So what is it not because it has two squared terms? It's not a parabola. Is it not a circle?
No, it's not a circle.
Why is it not a circle?
Because there are coefficients in front of the y and x.
There are, but I could get rid of them by dividing by 2.
But that's going to make a denominator between those.
Nope.
It's either an ellipse or a circle. It's one of them.
So I like that. It's an ellipse or a circle. Why is it not a hyperbola?
There's a plus.
Because they're plus. So it's either an ellipse or a circle. Because x squared and y squared are both positive. There's an x squared and a y squared, meaning it's not a parabola. They're both positive, so it's not a hyperbola. But because a equals c, because these two are equal to each other, then that means it's a circle. Even if you tried to work it as an ellipse, you would have the same denominator for the x stuff and the y stuff. And so if you went to graph it, you might go 3 left and right, but also 3 up and down.
Wait, is it supposed to be a equals c or a equals b?
A equals c because we don't have the b term. Right? The b term is not there. We're not going to have any b terms. So that's a and c. And again, the good news is if you tried to treat it like an ellipse, you would end up with the a equals b, and so you'd end up graphing a circle anyway. So if you went to graph it, you'd figure it out. If I just ask you for it and you put ellipse, you'd be close but not quite right. Well, speaking of that, you guys are figuring this out. Any way what could I tweak, since we had this narrowed down to circle versus ellipse, what could I change about this to make it an ellipse?
Minus.
What would a minus make it? A hyperbola. So it's still got to be plus if I want it to be an ellipse.
Plus y squared.
But that's what it is already.
No. Plus another y squared.
If there's, well, I don't want to add another y squared. That'd be 2y squared, and then it'd be a circle.
No. What?
2x squared plus y squared. The rest of this isn't really going to matter.
I said on the original equation if you put plus y squared.
Yes, this would make an ellipse because A and C are not equal to each other.
Or could we have made it 3y squared?
You could have made it 3y squared or 40y squared or 100y squared. Those would be, weirder and weirder ellipses, but they'd still be ellipses. As long as both of the squared terms are positive, it's a circle or an ellipse, and then you got to be a little bit more careful. All right, what if I wanted to turn that thing into a hyperbola? What would I need to do?
Minus.
Minus. Make one of them minus. Only one of them, though. So minus y squared. And really, the rest doesn't really matter at that point because it's only the squared terms that determine which conic it is. The rest of that stuff is about completing the square and graphing it and figuring out exactly where the center is and all the rest. But if we just want to know what shape it is, just knowing the squared terms is enough. So that would be a hyperbola. Well, there's only one left. What's the giveaway that an equation is a parabola? Good, it only has one squared term. So maybe it's 2x squared, no y squared terms at all, and then the rest of it. And again, the rest of it doesn't really matter in terms of what shape it is. It matters where it is, what it looks like. But if there's one squared term, it has to be a parabola. All right, we're about halfway through with notes, but instead of working more examples, let's work some off of the homework together. So find Unit 4, Worksheet 4. Identify and put in standard. So for the first three, go ahead and identify them. Don't put them in standard yet. That takes a little bit longer. But for the first three, put those, or just look at them and see what shape they are. Actually, first four. So 1 through 4, identify them, and then we'll compare notes on that. All right. So there's the first four: circle, ellipse, hyperbola, parabola. You want to keep going? All right, well then do the next two, and we'll see what those look like. So 5's an ellipse, 6 is a hyperbola. Slightly tweak the instructions. Let's only do the odds in standard form. So you're already done with 2, 4, and 6. All I wanted you to do was list to identify the shape. 1, 3, 5, I want you to put it in standard form. So some of you are starting that already, so what the heck, let's do number 1, and then we'll move on to the next thing. So try number 1 right now, and then we'll show the answer to it. All right, so half it, square it, add it. Well, I guess group them first. Half it, square it, add it to both sides. Be careful, big numbers, but you got a calculator. And it turns out that the radius is just 3. And sure, that would be off a normal graph, but that's okay. We're not graphing that one. We're just putting them in standard form. So that leaves 3 and 5 for you to do, to put in standard form. All right, back to the notes page here. So that's identifying. We've done enough of that. Let's talk about solving systems Solving systems of non-linear equations. What a mouthful. Solving systems of non-linear equations. Solving, we're just going to go word by word here. Solving means find x and y. So your answer needs to be, x equals 7 and y equals 3, or whatever you get. Systems means more than one. So this isn't just one equation, it's more than one equation. For us it'll be 2, but in theory you could have 3 or 4 that you had to mess with. Nonlinear, well, that means not a line. So things like, ellipses, circles, parabolas, hyperbolas, the things we've been working on. So we're basically looking for their intersection. And we could have any number of answers. So you think about how a parabola might intersect an ellipse. We could have up to 4 answers. Right? Because there's 4 places where those intersect. And you could draw all sorts of combinations of these, but I think the most intersections you'll ever get is 4. Again, you can try some things. There's a hyperbola. And if we did a little skinny parabola, that'd still be 4 intersections. So maybe as many as 4. Could be as few as none, right? If you had a circle and a hyperbola, or a circle and an ellipse that didn't intersect at all. So you could have 0 solutions up to 4 solutions.
Could you have if 2 hyperbolas intersect with 1?
Could you have, I guess you could have 8. We won't have 8, but you could have 8. Yeah, if you arranged it just perfectly. No, that would only be, oh, I see what you're saying. So this and that. Yeah, something like that. We won't ever have 8, but I guess you could get 8 if you really got them just right. We won't have to worry about 8 of them. The methods are methods that you already know. In fact, let's switch to the worksheet and work on it. So number 7, I think I would use substitution. Substitution. If x squared equals 2y, then that means I can substitute 2y for x squared. So I'm going to substitute the second thing into the first thing and have 2y, because x squared is the same thing as 2y, plus y squared minus 4y equals 0. And now I have an equation with one variable. This should be easy to solve. Y squared minus 2y equals 0. And then here's the second reason I picked number 7 to do. What do I need to do to solve that? I could complete the square. I could quadratic formula, but even easier than that, just take y out. Yeah. So y equals 0 and y equals 2. But I need the x coordinate as well. So I'm not done yet. I need to find the x coordinate. So x squared equals 2y. So x squared equals 0. That means x equals 0. So one of my points is 0, 0. For y equals 2. And by the way, I can use either of these, but I'm just using the easier one. X squared equals 2y. So x squared equals 4. If x squared equals 4, what does x equal? You guys are all half right. Plus or minus 2. So that comes up a lot. So when y is 2, x is plus or minus 2. So I think I'll just write that as, I don't want to say write it as 1 point because that's really 2 points. So this one had 3 solutions. And if we graphed it, we could figure out how that is. Let's see, that's a circle and that's a parabola. You don't have to do this, but a circle and a parabola could have 3 if you did it just right. So something like that. I don't know if that's what that looks like, but that's how you would get 3 solutions for this particular problem. Let's look at number. I think the rest of them are elimination. Number 3 works for me. Elimination means we should be able to add them together and hope that one of the variables goes away completely. So if I add those two together, and most of these are kind of set up already to make this happen. If I add those two together, I get 2x squared. The y's go away, or the y squared goes away. Minus 24x. The y's go away. Equals 0. The 64's go away. So that got a lot simpler, a lot quicker. That looked terrible, then it turned out to really not be that bad. So I'll factor out the 2x. That leaves x minus 12. So x equals 0 and x equals 12. And now I need to go back and plug those in to see what the y coordinates are when x is 0 or x is 12. And I might get 2 answers for y, especially with the y squared in there. I can use either one. You got a preference on which one we use? The first one or the second one? I like that. I like that idea a lot. That's probably the best way to go. The second one, because y squared is positive. Plugging in 0, that's going to make this really easy. Y squared minus 16y plus 64 equals 0. That's y minus 8 squared. So y equals 8. So 0, 8 is one answer.
Thank you for following all social distancing and mask guidelines. While transitioning, please remember to walk on the right side of the hallways and staircases. Congregating in the hallways and common areas is not permitted. Again, thank you for wearing your masks appropriately and remembering to practice proper hygiene such as hand sanitizer.
This one looks terrible, but the 144's cancel each other out. And you end up with y squared minus 16y plus 64 equals 0. It's like, well, that looks familiar. We just did that problem. So 12, 8 is the solution to that one. I think on all the rest you can use elimination. So add them together, something goes away, and then go from there.